Hey everyone, Dr. Marie McNeely here, welcoming you to episode 619 of the People Behind the Science podcast. This week we are revisiting our interview with esteemed scientist Dr. Randi Martin, originally broadcast on February 9th of 2015. Listeners, Randi is a force in the fields of psychology and the neuropsychology of language. She has studied different kinds of short-term memory loss and how they impact a person's ability to learn new words and also understand sentences. Her neuroimaging studies on a wide range of people with and without neurological damage or injury have advanced our understanding of language processing in humans. And in our interview, Randi discusses a variety of aspects of her life and research. So we hope you enjoy hearing her stories in this episode of People Behind the Science.
Every day, discoveries are made that will change our understanding of the world around us. Dr. Marie McNeely is here to bring you the brilliant minds who are making these discoveries so they can share their incredible stories and take you on an amazing journey. Welcome to People Behind the Science.
Hello, everyone, and welcome to another episode of People Behind the Science. I am delighted to be here today with Dr. Randi Martin. So welcome to our show today, Randi. How are you?
I'm just fine.
Wonderful. Well, we are delighted to chat with you today. Listeners, Randi is the Elma Schneider Professor in the Department of Psychology at Rice University. She's also an Adjunct Professor of Otorhinolaryngology and Communicative Science at Baylor College of Medicine. Now, Randi received her master's degree and PhD in psychology from Johns Hopkins University, and she served as a visiting lecturer at the University of California, Santa Cruz, and an associate research scientist at Johns Hopkins University before she joined the faculty at Rice. And Randi has received many honors and awards during her career, including being named a Fellow of the American Psychological Association, a Fellow of the American Psychological Society, a Fellow of the American Association for the Advancement of Science, as well as election to the Society of Experimental Psychologists. Now, Randi is generous enough to join us today to tell us all about her journey through life and science. So, Randi, today we want to get to know you, both as a scientist, but also as a person. So can you take a few minutes here right off the bat to tell us what you like to do when you're not doing science?
Sure. Well, in terms of hobbies, there are probably two things I like to do a lot. So when I have spare time, one is dancing, any kind of dancing, partners dancing. So my husband does it with me. And we've taken all kinds of lessons. So we do country western and swing and salsa and ballroom and so forth. We're not great. We're not in contests or anything.
No competitions for you.
No, we're not on Dancing for the Stars or anything like that. But we really enjoy it and try to go out with friends to go places to go dancing. We're going to do that tomorrow, actually. So that's one thing I really think is fun. And then another thing I do is a lot of reading of mystery novels. So, of course, I do a lot of reading related to my work, but my spare time, a lot of my reading is mysteries. And some reason I've focused on Scandinavian authors lately, like Henning Mankell and Joe Nesbo. So I guess I like logical reasoning, trying to go in to figure out who did it. But yeah, and nothing do have it usually in this extracurricular reading.
Gotcha. Well, it is wonderful to hear, Randi, about your hobbies, these things that you like to do when you're not at work, and wonderful to hear that you've specialized in all these different types of dance. I love it. And reading is definitely something that I like to do with my free time, kind of get away from science, pick up a nice light book, a mystery novel, something like that. So great to hear that you're able to do this as well. So can you tell us, do you have a particular book that you've just really enjoyed that you would recommend for myself and our listeners to check out?
Yeah, so the book is called The Signature of All Things, and this actually is a book about a woman scientist, a botanist, and it's around the turn of the century, late 1800s, moving into the 1900s. Her father was a botanist as well, and so it was highly unusual at the time for a woman to be pursuing this kind of career. And it's talking about her love for science and her love to travel, to search out exotic plants, but also about her personal life and, what was expected of her in terms of self-sacrifice and taking care of her father, and partly because of that, not marrying. And a lot of it's just about the inner conflict for a woman in that time, as well as, things you can still relate to today. And also making her way in science. And it also brings in the intellectual transformation at the time of Darwin's theory of evolution coming in, and, how that was playing into the science that she was doing. So I think it's just a fascinating book on many levels.
Well, that sounds like an excellent recommendation. Interesting to hear that there is almost this historical element of a woman at that point in time going through this career as a scientist, but also a lot of lessons about a lot of experiences that scientists can relate to today. So wonderful recommendation. We'll put that out on our website, on our resources tab for our listeners to find. And I love getting these book recommendations. It almost tells you a little bit about the person you're talking to, but also selfishly gives me a little bit something to read when I have a little bit of free time there.
Yeah, I'm always looking for good recommendations too.
Certainly. So now diving back into your scientific side, we've talked about what you like to do when you're not doing science. But can you tell us next, Randi, about how you describe what you do to someone who might not be in science?
Yeah, sure. My research is really in the area of what's called cognitive neuroscience. So I'm looking at how the brain carries out language and memory functions. So I do that by looking at both individuals who've had brain damage. So it might be people that have had a stroke. That's mostly what we look at. Occasionally people that have had head injury or perhaps dementing disease. And in looking at those patients, we're looking at what abilities are spared versus what are affected, and how does that relate to the different parts of the brain that have been affected. So trying to map from the patient symptoms into the brain areas and the brain systems that are carrying out these different functions. And then the other side of that, come in more recently, is carrying out functional neuroimaging. I think most people have seen a lot of figures of that these days in the newspaper or other places of, looking at healthy, young or older subjects in an MRI scanner while they're carrying out some language or memory task, and then from that looking at the parts of the brain that get activated while they're doing that task. And so we're pursuing both and trying to map them together to see if they come up with a converging story about what the brain regions are that are involved in these different functions.
Certainly. Well, a very interesting area of research. Myself, as a neuroscientist, I always get excited when I'm chatting with other neuroscientists on our program. So great to hear a little bit about your research. And we'll talk later about some of the current projects that you're working on. But I'm always curious when I chat with scientists who are so busy with all these different things that they like to do in their lives as scientists, but also out of their lives, kind of balancing everything. I'm curious about what motivates people. So can you share with us today if you have a particular motivational quote or maybe a saying that you love to keep in your mind to get you through every day?
Yeah, I have a few, and actually I don't necessarily have a lot going through my mind, but there have been some things that have come up last few years, particularly that have been helpful. And one is, remember that what you now have was once among the things you only hoped for.
I like that.
Yeah, so I think this is quote related to gratitude, I guess, and also just appreciating how far you've come and what you have accomplished. Because I think in science, people are very ambitious, I guess, and they always do more and do better. And you're always getting critiques from articles that you submit or grants that you submit, or things might be going on in your department that you're not so happy with, and maybe you start feeling bad. But then, if I really think about how great really things are compared to where it started a long time ago, and, just the thought that I am a professor at a great institution with wonderful students and a lot of support for research, and I'm really able to pursue what I love to do, which a lot of people cannot.
Right. Helps put things in perspective, definitely.
Yeah, I think thinking about that just really helps.
Certainly. Well, that is a great quote. I love these themes behind it in terms of having these moments of appreciation, of gratitude, of reflection, and really keeping that in the back of your mind as you're going through. And I think you're right how you're describing scientists as being these very ambitious people. And you're kind of always getting these critiques. You're always getting ways to improve, to get better, to work harder, things like that. You don't always have time to stop and appreciate how far you've come.
Yeah, I remember this one ad that was on TV of a woman giving a talk at a conference, and then people in the audience were holding up like 9s and 10s.
Yeah.
In the audience, as if it was a gymnastics routine or something. And it was just so funny because you never get that, you never get that overall sense of the audience and positive feedback.
Right.
Always a critical question,
You might get some clapping at the end if you stick the landing, but after that, you're done. Yeah. Well, that is a great point to bring up and wonderful motivational quote, like I said. And in addition to talking about these motivational factors for people, what gets them through the tough times, I like to talk to people about their journey. And in particular, focusing first on some of these people along the way who you've met, who you've worked with, who really inspired you or maybe served as a role model.
Okay. The first person I could really think of was a high school teacher that I had, Mr. Rasmussen. He taught my math class in the 10th and the 11th grade, and he was so knowledgeable and so logical. And I remember that at that time, it seemed like a lot of our math teachers were, for some reason, basketball or football coaches.
Gotcha.
He was actually quite an expert in mathematics. And, not only was he a great teacher, but I remember him giving me a lot of confidence. He did compliment me on how I was doing in the class and encouraged me to pursue this kind of direction in the future and going to college. He also would talk to the class about things outside of math that he was concerned about. So I remember him talking to us about how Oregon was really cutting back on funding for schools and what that was going to do to the education system. It was just refreshing to have someone share something like that, sort of treat us like adults, let us know what his opinions were, let us talk about it. So I really appreciated both things from him. Beyond that, my graduate advisor was Alfonso Caramazza at Johns Hopkins, and he was inspiring in that he really made you focus on what was the important scientific question. And it just would always bring that up, like, what is the issue here? What is the big picture? Why is this important? Because it's easy enough to get sort of immersed in the fine details of your experimental design and tweaking this thing or that, keeping that focus on what's important. And also, he was fearless, I guess, in challenging the status quo. So that was inspiring to be around. He also challenged us, so that was
stressful but inspiring.
It could sometimes be a little fear-inspiring, but you learn how to deal with it. You learn how to stand up with it, and it puts you in good stead for things down the road. A third person I could think of is Dr. Lynn Hasher, and she's a memory psychologist at the University of Toronto. And I've just interacted with her over the years at conferences, visited her university. And she's just such a great balance in her life, I think, between her work and just also the way she interacts with people. So she's made a lot of great contributions and discoveries in the field of memory and aging. But she's an extremely nice person. She's very supportive of her former students and postdocs. She can be tough as well. She was chair of their department there for a while. But I think just watching her, you can see how somebody can be a top scientist, but also maintain their humanity.
Certainly. Well, I love hearing about these people, these mentors who had a big impact on you, and definitely these little lessons that they imparted upon you on your way as a scientist going through this journey. So great to hear about these. And I especially love this description that you had of your high school teacher and how you specifically remember the encouragement you were given. And I think that's something that a lot of teachers may not realize, just these offhanded comments, these little compliments can mean so much to the students. So great that you brought that up. I'm curious now, Randi, can you take us back even farther maybe and tell us where your interest in science began? Was there a certain point where you realized that you were starting to get interested in the world of science, or particularly in neuroscience, and maybe hit some of these key moments along the way that really got you to where you are today?
Okay, well, the thing I can remember earliest, it wasn't really related to neuroscience. When I was in the third grade, actually, because of Sputnik and all the fears in the U.S. about, the Soviet Union was outpacing us, they wanted to encourage kids to go into scientific careers. And I remember they took some of us that were kind of in the advanced group in the class to go to this special class where they took us on field trips. So we went to the Oregon beach and we went to the mountains, and so we were looking at marine life at the beach and geology up in the mountains. But what I really liked about that experience was not those two things, but this session we had on learning to break codes. And so getting a code, and then you had to figure out how to translate that into English, what was going on. And it was just fun. It was just logical puzzle solving, I guess, was what appealed to me about it. And then the next thing I remember was seventh grade, where sort of a part of this whole push of emphasis on science and math, that they created this new math curriculum from Stanford Mathematical Study Group, I remember was the name of the group that put out these math textbooks, and they were all yellow, and they had this paperback cover because they were kind of like hot off the press, I guess, from Stanford. And we had them in our math classes, and the whole approach was very different. It was very abstract, logical. I don't know. It just made sense to me. I really liked it. And I know a lot of people didn't like it at all, but I really liked it and kind of stuck with it all the way through junior high and high school. So I was really directed towards math rather than science. But then when I got to college, I was an undergraduate math major for a long time, but I got to a point where I just couldn't see myself going into that as a career. Envisioning
a position or something like that.
Yeah, working in industry. Actually, I had never thought about going to graduate school at all, because the only person in my extended family that had gone to college before me was my older sister. And so my parents and everyone else had not gone to college. So just going to college was a big deal. And it entered my mind to think about graduate school at all. But from distribution, you have to take so many social science classes, whatever. I took psychology, and there were professors there at Oregon at the time that were kind of in the forefront of this field of cognitive psychology. So it was like the turn away from behaviorism into the study of the mind and so behavior. And there are people there at the forefront of that whole, what's called the cognitive revolution. And they taught the intro classes in psychology. So I just remember it was so fascinating. I thought that you could scientifically study, how people remembered things, how people learned things. And so I just loved that and ended up taking a lot more classes and thinking that this was a way to sort of marry my interest in math and potentially statistics, to use these analytical techniques in this field that I found so fascinating. But even at that point, I didn't think about graduate school. I actually took a job in industry. I was working at Pacific Northwest Bell Telephone as kind of a low-level management person. And I remember that we had all these Bell Labs technical manuals in our office because part of my job was sort of managing this new switching machine for phone calls that was going to be all software-based instead of hardware-based. And I read all these Bell Labs technical manuals about this just to figure out how it worked.
That's some great bedtime reading right there. Yeah.
I wrote up this summary, which I don't know if anybody was interested in except me, but I figured that, from that I really wanted to go back to academic position and not be in management in an industry. So that's when I decided to go back. And I actually applied to psychology programs. I applied to places that had like a strong quantitative program or a strong statistical, methods in psychology program. But I kind of had in the back of the mind that I actually wanted to go into cognitive psychology. So I chose places that had strong cognitive psychology as well. And so that's kind of how I ended up at Johns Hopkins. They had both things there. And so I, in fact, did do quantitative, but then kind of toward the end of my graduate career switched over to cognitive. And then when I did the postdoc, the studies I did for my dissertation were just sort of normal psychology studies with your average undergraduate student looking at category learning. That was my topic. But when I did a postdoc, I remember hearing about this brain damaged patient who showed this syndrome, a reading syndrome that's called deep dyslexia. So in this syndrome, the hallmark of it is when they're reading words, they produce semantically related words. So they might see a word like lady and say woman, and they might see a word like mirror and say reflection. And it just seemed so fascinating to me that how could this possibly happen?
Right.
How could you see one thing and then come out with something that doesn't look or sound.
It's not phonetically the same, yeah.
What you're reading, but it's semantically related. So information must have gotten into the brain, into a region that represents the meaning, and something close to that has come out. So I remember just thinking that was really amazing, and that must tell us something about how the brain is organized. This can happen when there is brain damage. So I think that was one thing that really inspired me to pursue this direction in the postdoc. And person I was working with was doing research in this area, looking at aphasia, which is language deficit after brain damage. So I jumped into that and started pursuing that, and have been doing it ever since. So I really, really enjoyed it. And I think one thing that you find with working with these patients like this is just how surprising their behavior can be. So you go in and do some test, and they will just do something that, totally unexpected, blows you away. But that's what's so fun about it, is that these unexpected things can come up, and then it sends you down this direction to try to figure out what's going on. So I've just really enjoyed that. And then the thing that's, as I mentioned, talking just briefly about what I do, the other thing that's become available now a lot more is to get really detailed MRI scans, both structural MRI scans, what's damaged in these patients, what brain regions are damaged, and so that you can carefully look at that across patients showing certain symptoms or syndromes, and so you can do a much more objective way of correlating the two than it's been possible in the past. And then also looking in, healthy subjects. So if you have a hypothesis, okay, this region's involved in short-term memory, or this region's involved in understanding verbs or something, based on the patient data, you can, design a study with healthy subjects to see if that same thing comes out or not. You get converging evidence for how things are organized. So I still make use of my mathematics, but mostly in statistical analysis. I think that it was a great background to have that confidence and background in math, because I think a lot of people that get into psychology, they don't really have that strong a background, and then, may struggle when they get to the more quantitative and statistical parts.
Definitely. Well, Randi, it sounds like you have had a wonderful journey to get to where you are today as a scientist. And I love this description about how it all began, this early love of math and problem solving, this third grade you starting a little code breaker kind of project, and really just getting hooked on these concepts in math and science, and kind of moving from there into psychology and then more into this cognitive psychology, neuroscience area. So really interesting to hear about your path to where you are today. And I think definitely these advances in brain imaging have been so exciting over recent years. So can you dive in and tell us a little bit more detail now about one of these projects that you're working on currently that you are maybe the most excited about?
Okay, I think the one I'm most excited about right now is one we're doing on acute stroke. So what we're doing is going in to stroke units at a couple hospitals here in Houston and trying to get patients who are within 72 hours of having a stroke, and within that time frame doing behavioral testing with them on language and short-term memory, as well as we get their clinical scans. I think we're moving to trying to add some other scan information onto that. And so we're getting what the behavior is like, what parts of the brain are damaged right away. And then we're going to test them at 1 month, 3 months, 6 months, and a year post-stroke. And at each time point, redoing the same behavioral testing and also getting all of the MRI scans, different kinds, at all those time points as well. So those scans not only tell you what parts of the brain, the gray matter, the neurons have been damaged, but also the tracts that connect different areas. So getting both of those. Another thing that we're getting is to look at what's called the penumbra around the lesion, which is a region where the cells haven't really died, but there's reduced blood flow. So we're going to get that too or trying to get that now from the acute strokes. We can get it from the other ones subsequently, because that's important to see, does that tissue actually come back or does it die out? If it's partially damaged acutely, but it comes back, does that really predict recovery of some function? So the exciting thing about looking at acute stroke is that you can look at these brain behavioral relations before there's been any time for reorganization of function. So
very interesting.
You recover from stroke or head injury and, different parts of the brain that didn't carry out some function previously may take over this function that's been disrupted. And so we can go in and see what's happening acutely before reorganization has happened. And then as we test them down, we can see if, in fact, there has been reorganization of function, has tissue, right alongside the area that's damaged, has that taken over this function? Has maybe the other hemisphere, if they had a left hemisphere stroke, did the right hemisphere take over? So there's a lot of very interesting questions on how behavior and brain correlations will change over this time. The other thing that we're looking at is more theoretical questions related to issues that I've been interested in for a long time. That is, how does language comprehension depend on your short-term memory capacity? So we can see if patients that improve in short-term memory capacity over these different time points, does that predict the improvement in their sentence comprehension? So you expect that to happen if those two things are dependent on each other. If they're not really, if language comprehension doesn't depend on that, then it won't necessarily show that those two things, improve in concert across this time. And the final thing we'll be able to look at is is there anything we get acutely that is going to predict what the person's behavioral outcome is a year later? So that would be an important thing to know. It's more of like a clinical implication. Could you tell from 72 hours, can you tell where this person's likely to be in a year? And if the prognosis is not good, would it make sense to target intensive treatment at that patient to help overcome that predicted outcome?
Definitely. Well, Randi, these are all very exciting areas of study, and I think definitely have important real-world applications to stroke patients who are struggling with these issues and not having that information of kind of what the longitudinal data look like and what we can anticipate in terms of their outcomes, what sort of early interventions we should be planning or could potentially plan to help them out later. So very, very interesting projects that you're working on. So great to hear about some of these big things happening in your lab. And I think so far we've talked about a lot of the positive aspects about careers in science. We've talked about these exciting research projects that you're able to work on, your journey to get to where you are. But we haven't yet touched on really too many of the struggles that scientists have. And I know every scientist goes through different periods throughout their career where they have these moments where they're really struggling with something, maybe for days, weeks, even longer. Can you take us back to one of these challenging points that I think are not often talked about in science and tell us what happened and what are some of these steps that really got you through this tough time?
Well, one really tough time was right after I got my PhD, and at the time it was some reason, and I don't remember the circumstances of why exactly, but it was suddenly a very tough time to get an academic position. It could have been that there'd been all this expansion and a lot of government support. In the 60s, a lot of people hired, but by the time I got my PhD, in all those positions, and there weren't a lot of openings.
Right. I think this will resonate with a lot of young scientists now, too.
Yeah, I think you're right. Similar thing happening. And the faculty at Hopkins were not used to this either. I mean, they were used to being able to place their students. You know, somebody got out, several of us were struggling that they thought should be able to nail something down. And I remember all I got offered was a one-year position. So that was that 1 year at UC Santa Cruz position. Mm-hmm. And I got there, and I was doing a lot of teaching, and I hadn't really had that much teaching experience from my graduate training, and teaching things, you know, that I hadn't really had a lot of preparation in, as I recall.
Gotcha. It's a stressful time.
Drug you in. And then also not having a lot of time for research after emphasis of my graduate career was on research, and, you know, not having a lot of time to work on that, and just wondering, you know, what's going to happen after this year is over in terms of where am I going to go from here. And also my husband, you know, it was hard on him too, because, you know, does he want to move around the country for a 1 year position to be with me? And he actually, for a while, we ended up being apart, and he was at the University of Montana studying geology, and so, you know, we were not together, so that was difficult. Along the road here, I got an offer for an applied position at Bell Labs, and it was in some ways tempting because it would be a permanent position. It was an applied research. It wasn't basic research. They had some basic research labs there, but this wasn't one of those. It was much more applied. And it wasn't, you know, really what I wanted to do, but on the other hand, you know, they paid like twice as much.
Oh, wow. And it's a job in science, yeah.
Yeah, you know, and my parents were like, what are you doing? Why don't you take this?
Right.
By this time, I just really was in love with cognitive psychology, wanting to pursue these basic research questions. You know, one good thing about having taken a job before going to graduate school, so that it gave me a lot of confidence that if this academic thing did not work out, you know, that I could move into industry and probably do well. And so that was sort of always there as an option, but kind of knowing it was there, it made it easier for me to, let's say, well, I'm going to stick it out here in academia for longer and, you know, just see if something will come up. And so what I ended up doing, as I said at the beginning, was I went back to Hopkins and did a postdoc. And when I was doing the postdoc was when I got into the cognitive neuroscience with the patient-related research. And I was really so happy about getting into that field. And I was there for 2 years, and then I got the position at Rice. And you know, it was a great position. I was really happy to be here and been here ever since. So, but it certainly was a struggle. And besides just sort of having this self-confidence of knowing that I could go in another direction if I decided I wanted to do that, there's also a lot of encouragement and support from the person who'd been my graduate advisor, who just said, you know, I think you really have a great career in front of you, and just give it some time. I'm sure something good is going to happen. And so, yeah, just hearing that from him, and having this person who was becoming quite eminent himself at the time, having that
sort of vote of confidence in your court almost, yeah.
Yeah, that really did help me to hang on. And, you know, he certainly encouraged me to do this postdoc and stick with the academic career.
Definitely. Well, Randi, I think this is a great story to share. And I think, like I said, it's going to resonate with so many young scientists out there who are trying to figure out their careers in a tough academic job market right now. And I think there's a lot of uncertainty in the career path of a scientist that maybe not everyone realizes. I mean, it's a lot of these short-term positions oftentimes where you're maybe doing one postdoc, maybe doing up to 3-4 postdocs before you really settle down in a permanent position. So interesting to hear about how you were almost tempted away by industry, maybe some pressure from friends, family, people who couldn't quite understand what you were going for. But I think it's one of these things that a lot of academics experience. And I think it's great to hear that you had that industry experience before going off to graduate school. So you had that confidence that, all right, that's always going to be an option, but I want to pursue this academic path. I want to pursue my dream of doing academic research. So really interesting to hear this struggle that you had and how you worked through it, really just through almost persistence, patience, and having that confidence of knowing that you had other options if it needed to get to that point.
Yeah, exactly.
Absolutely.
And I'm certainly glad I did stick it out. So.
Certainly. Well, it seems that everything has worked out in your favor, and I am delighted to see that. And Randi, we don't just want to talk about the tough times in science. So I'd like to give you an opportunity next to tell us a little bit about one of these success stories, something that's happened that has really meant a lot to you. And it can be a big success or even just a little victory along the way.
Okay, well, this is kind of a major thing that just happened within the last year. So what happened was that I, together with the Dean of Social Science and the Development Office here at Rice, applied for and got a big grant from the TLL Temple Foundation to build out a lab in a new building on campus. So there's a beautiful new building. Well, it's been around now, I guess, since 2007 or so, called the Biosciences Research Collaborative Building. And mostly the people in it are in bioengineering or chemistry. It's more engineering and natural science. But a lot of people, including our dean and one of the directors here at the BRC, thought it would be important to get some neuroscience, some social science into the building as well. And so, fortunately, this foundation was excited about the proposals. The proposal had to do with neuroplasticity, so, fit well with the research we're doing now on the acute stroke and recovery from that. But, we're encouraging other kinds of research. We're actually doing a new study over here with some of the new equipment that we got. So not only did we get this large, beautiful lab space, so there's enough here for like 3 faculty members and several postdocs and graduate students. We also got a lot of nice equipment related to cognitive neuroscience. So there's what's called transcranial magnetic stimulation, which is a method for disrupting briefly cortical processing. So you apply this to someone's head and
right.
disrupts whatever brain tissue is under that for a short amount of time. And so you can kind of use it as like a temporary lesion or a temporary stroke. I mean, it's just a very small area that gets affected, but it's very precise. And so, again, it's a way of looking at areas that might have shown up in the neuroimaging. Okay, this region is activated, but then you can ask, well, is it really critical for this process, or is it just, some epiphenomenon somehow? It's not really necessary, but you see it. But if you can disrupt it, processing in that area, and then it disrupts the function, that tells you something more definitive about, okay, this really is involved. So we have that. We got equipment for what's called event-related potential. So it's measuring electrical signals across the brain. So it's not disrupting anything. It's just measuring what's going on across the scalp while people are doing different kinds of tasks. And the beautiful thing about it is that it gives you very precise timing information. So you can see, within 100 milliseconds of reading a word, what is happening in a certain part of the brain and how that pattern changes.
Well, Randi, it sounds like you have some amazing new equipment to work with to continue building your research program. And congratulations to you and your collaborators on this wonderful grant and all the opportunities that come along with it.
Thank you. Yeah, I'm really excited about it.
Absolutely. Well, that is a very exciting success. And I know there are a lot of wonderful aspects about careers in science, these brilliant successes that you have, the mentorship opportunities, the teaching opportunities. There's a lot of great things that goes along with it. But I think a lot of people may not be aware of some of the great travel opportunities that come along with careers in science. So can you think back now on all the places that you've traveled for science, for conferences, working with collaborators, training, things like that? And can you tell us about your favorite place that you've been able to visit, Randi?
Yeah, I think the favorite that I can think back over the years was a conference that was held in Lake Como in Italy, which is just a beautiful site. The conference was in a palace that was on a hill overlooking the lake. And it was a small conference, so I think there were only 20, 25 people that were invited. And it was on the neuropsychology of short-term memory. It's like in 1988, I think, so it was early in my career. And there were a lot of big names in research that were there. There was Elizabeth Warrington, and Tim Shallis, Alan Baddeley. So all these people that, just looked up to so much. And so I was so honored to be invited to this and to be able to rub elbows with these people.
In a palace, no less.
In a palace, yes. And, have these wonderful meals. I remember we took like 2-hour lunch breaks where we'd have this several course Italian meal for lunch. And so, I think that was my first time to really travel to a foreign place like that. And, I thought, boy, I've really got it made now. This is...
I've made it. I'm liking this. Yeah. Definitely made it seem worth it, sticking it through on the academic path. Well, I love this story that you've told us about your experience in Lake Como, staying at this beautiful palace for a conference. And it sounds like a great opportunity. And a lot of scientists really point to these smaller conferences where you really get to interact closely with people who you admire in the field as just great opportunities and experiences that they've had. So wonderful to hear your story here. And I think in addition to these colleagues that you have that you work at conferences, we've talked about some of your mentors, some of the people that you've been able to work with over the years. And I think this is another one of the wonderful aspects about being in the world of science, these people that you get to work with. And I think there are stereotypes about what scientists are like, but I think there are so many different types of people in the world of science, and many of them are just amazingly creative and brilliant and funny, and you have a lot of fun working together. And you take the science very seriously as well. And I think with this, you get some quirky traditions that spring up and even just some funny memories that you can look back and laugh about. So can you share with us today, Randi, a quirky tradition that you've experienced in science, or maybe just a funny memory that you have?
I was having some trouble kind of thinking of something. And the only thing I could think of that happens in my own lab, which isn't a little bit quirky, but I guess it's not that strange, is that we celebrate birthdays of all the graduate students and the undergraduates that are in the lab. But instead of somebody organizing the birthday party and getting cake and whatever, it's the job of whoever birthday it is to bring the cake.
All right. They get to pick their own cake. I like that.
So they can bring cake, or they can bring chocolate mousse, or, whatever their favorite thing is. So this is good. They get to choose what they like, and, no one has to remember this.
That's what I was going to say. You don't have to remember everybody's birthdays. They just bring it in.
Everybody remembers their own. And so, this has been a great tradition that we keep going.
Gotcha. So, Randi, on your birthday, what do you like to bring in?
Oh, I like key lime pie.
Ooh, good choice.
Yes.
Well, it's wonderful to hear about this tradition that you have. And I think a lot of these little traditions, these little opportunities that people make to bring the lab group together are so key for making that wonderful collaborative lab environment and keeping all your students and the people working with you happy. So great to hear that you have this wonderful little tradition of taking time out of your day to celebrate people's birthdays. Love it. So I think in addition to these traditions that you form with the people in your lab groups, you get to chat about these big questions. And we've talked about some of the research that you've done, some of the research that you're working on now, but we haven't yet chatted about these big unanswered questions in your mind, Randi. So can you tell us, if we took all the obstacles out of your way, if things like funding and staff and technology and feasibility were not an issue anymore, what is one research question that you are just dying to know the answer to?
Well, one thing that is intriguing me right now, it'd be hard to write a grant on it at this point that would have any chance of getting funded, but what I'm really curious about is what is it that lets some people recover and others not in terms of what's going on in their brain following a stroke, let's say. People right now don't have a very good idea. So any kind of treatment that's applied, treatments that certainly work, behavioral treatments in conjunction with logical treatments or drug treatments, people can improve, but there's huge variability in who recovers. So one thing that has been intriguing me is that when there is recovery, and let's say people have lost a lot of their vocabulary, their names for things. Mm-hmm. So if they recover that, is the recovery due to changes that are just going on kind of at the more surface levels of the brain, that this rapid mapping, relearning? I don't think we really know. Is it purely a more cortical level, or does it depend on connections between those levels and more central brain regions, like what's called the hippocampus, so people know that that region is important for learning and memory, but it's not so clear that it's important for the kinds of things that you learn in language. Episodic memory, where you remember specific events and a time and a place. When you're learning words, you don't remember where you heard it or who said it or whatever. It's more abstract kind of knowledge, and it's not so clear how much this medial hippocampal regions are involved. So I would just be fascinated in being able to do that and trying to track out the connections between these central regions and the more cortical regions. Is that critical, or what exactly is it?
Well, I think this is a very intriguing question. I like how you're starting to kind of map out an approach to how you would go about solving it. But I love that you brought up this point too of, I'm not exactly sure how I'd write it up in a grant, but I think that's something where a lot of researchers have to frame their questions now kind of with this restriction of, all right, how would I propose it to someone who I'm trying to get funding from? So
yeah, because it's gotten a lot more expensive to do a lot of this stuff. So it's hard to do, a little experiment in your lab with flashcards or something. So a lot of the new equipment is wonderful, but it's expensive.
Comes with a price tag, definitely. Well, Randi, great to hear about these big questions that you're thinking about now as a scientist out there. And I think in addition to throwing these big questions around with your colleagues, I think scientists get a lot of great advice from the people that they work with, from the people that they've been mentored from over the years. So can you share with us today what you would consider just the best piece of advice that you have ever received?
Well, I think one important piece of advice is just to hang in there and keep trying. So as we talked about earlier, you run into a lot of rejection of papers, grant proposals. And I've heard that a lot of young people, they submit a paper and then they get back, well, we can't accept your paper, but viewers have these critiques, and we might consider it if you'd revise and address all these things. And I've heard that a lot of young people just give up at that point, that they think,
you feel like you failed there, yeah?
I failed, yeah. Where, more senior people say, no, that was a good outcome.
Yeah.
They're asking you to resubmit. They didn't totally.
They took the time to tell you what was wrong with it. That's great, yeah.
They didn't just say, go away, I don't want to hear from you. So, yeah, you got to keep trying. So you revise it, you send it back in, and, maybe it won't work at that journal, but, you may be able to make further changes, send it somewhere else. And so there's just a lot of kind of stick-to-itiveness, I guess, that needs to go on, and kind of getting beyond, something that can seem like a pretty dramatic blow at the time, and just realize this happens to everybody, and it's just a common thing. And you've got to believe in yourself, and, believe that you're going to be able to make it here at some point. We just got to keep trying. Particularly, I'm thinking about papers and grants, but all the aspects.
It has wide applications. Well, I like this, Randi. I think these themes of persistence and confidence keep coming up in our conversation. That's great. So, a wonderful piece of advice. Now, I've really enjoyed our chat today, Randi. Can you tell our listeners how they can reach out to learn a little bit more about you or your research?
Well, they can certainly email me if they're interested. So it's easy email. It's rmartin@rice.edu. And if you just Google Randi Martin at Rice, webpage pop up, and so then you could look on there and get some more information about things going on in the lab, people in it, and the kinds of projects that we're working on as well.
Wonderful. Well, listeners, definitely check out the website. Get in touch with Randi if you have any questions. And Randi, thank you so much for taking your time to tell your story with us today.
Okay, thank you. I've enjoyed it. It's kind of fun to think about all these things and the history that I've gone through.
Well, it has been fun to chat with you as well. And thank you to our listeners out there. Join us again next time for another episode of People Behind the Science. Your voyage to the lives of today's exceptional scientists has just begun. You can find everything we talked about today, including our guests' favorite books, biographies, photos, and more, when you visit us at www.peoplebehindthescience.com. I look forward to seeing you next time on People Behind the Science.